So what is logic? Anybody have an answer what they think logic is? 5-letter word, good. What else? You are right. Anybody else want to add something to it? Yeah. Thinking empirically, and now we gotta, now we gotta define what empirical means. Using what? Facts. Yeah, you're using stuff from the past, evidence, facts, something from the past to then figure out your future steps. So you're using stuff from your past, stuff from your history, stuff from things that happened in the past to say, I'm not going to do that because that's what happened. Or I'm not going to do that because that's what happened. You see, you're deducing what you're going to do based on empirically, based on the past. Does that make sense to you guys? So, what type of professions use a lot of logic? If you're basing everything on evidence, basing everything on history, and to make your decisions now, what type of professions use that? A lot of them. Let's throw some out there because a lot is general. Well, me, I already told you I'm a computer programmer. I use logic in every program. You haven't used logic yet. You've just used, output statements that print things to the screen, and you've done some things with it, and you've learned what a variable is to store data, but we haven't done anything with the data. So we haven't formed any logic yet. Okay. So what other professions use it? Anybody? Go ahead and tell me. What do you think? Engineers. Where would they use evidence? Well, they got to use evidence with their, their formulas they're using, whatever they're building, whatever they're creating. What else? Somebody else? Scientists. Yep, I'll kind of classify them with engineers. They're not always the same, but yep. That's spelled right. I'm really terrible with spelling, but we got that. What else? There are some more general ones out there. There are some more ones that, do base everything on facts and don't move forward unless you have facts laid out. What is another huge profession? What is it? A lawyer? Is that what you said? Or a doctor? I couldn't hear you back there. Lawyer. Okay, yeah, you like lawyer better, right? Well, but doctor's great too, both of them. Why would a lawyer use evidence? Because everything they do is based on some prior case, right? Everything they do is based. And what was the? Well, you actually said doctor, right? Yeah, because doctors are a little different. Depends on what type of doctor. Sometimes doctors, try things. They try new things, and that's not based on evidence. That's not logic. That's just, we're going to do a trial. We're going to do something different. So some doctors, but a lot of doctors, base it on former patients. Whatever those patients had, we're going to whatever diseases, whatever happens to these people, now we're going to determine what we do in the future. Okay, there's plenty of them out there, and so you might not realize, like most degrees, most careers that you choose is based on logic, but the logic is kind of behind the scenes. What you do to get there. You could not be a good lawyer unless you applied logic. Because to get to the end of the case, you have to provide evidence of all these different things to prove your point, and then you can prove it to the court. Computer programmer can't get through a program without logic either, because a computer program is sequential, like what you learned. And I'm just going to hopefully grab a black pen right there. So what you learned is you program everything in this white screen right here. Here's where you put your .java file. And you program everything in this white screen, and you put sequential lines of code here. And those sequential lines of code then output something in the execution screen, the black screen, so that, or whatever color you made it, so that then it performs this logic in that order. There is an order. Each one of these lines of code happens in that order. If you're one line off, it changes everything. If you change the variable value and then you output versus output and then change the variable value, you'll see a different outcome. Okay? So the logic that you put into this matters. And that when you get to if statements are your big component of logic that you're going to apply to a program, where it might say, guess what, we're going down these 5 lines right now, and now we reached an if statement. And if you reach an if statement, you can actually send yourself two different directions. You could say, if it's true, go this way. If it's false, go this way. And if that's the case, you've just introduced that there could be two different line 6s in your program. Does everyone see this? Because if something happens and it's true, it can go this way. If it doesn't happen, it's false. This is where gaming, this is where gaming evolves, where you can say, hey, I'm going to build into my program the ability to go one way or the other. You know, if you didn't have that, every single game would be the same. You play the same game, and now every single time you jump over that mushroom, it's the same speed, the same time. That's not a game then. If you do it exactly. Although Mario is very similar, you have to beat the Super Mario. You have the same things that come at you at the same time and everything. However, it's random what you decide to do, right? If you choose to turn backwards versus run forwards, now it changes things. If you jump at this time versus not jump, if you shoot at this time, it's all what you do, but the input that you provide that changes what happens in the program, which means it becomes random, the game becomes different, and now here are these if statements that say one thing could happen or another. Make sense? If Pac-Man eats that big dot, now all the ghosts blink and you can eat them. There's a big if statement that changes the entire game. Make sense? Okay, this is what logic is, but the fundamental of logic, or the fundamentals of logic, comes from the keyword if, and when we start writing these big if statements. This was one of the 6 major topics I said at the beginning of the year. And we will do what are called truth tables in the future. Truth tables not only introduce the logic, but they build on it. And truth tables get you to be better programmers, better at writing if statements, high level if statements. A very basic if statement like if Pac-Man ate the big dot, now the ghosts blink and you can eat them. You know, that's a very basic if statement. There's not much going on. But when I start adding these words in between, everything changes. And logic is based on these words. Okay? So if I said this happens and this happens, it's different than this happens or this happens. Now if I start stringing a not in front of it and say this happens and this happens, or this happens and this doesn't happen, or this doesn't happen and this happens, they all mean something different. But in the human language, it doesn't. Okay? And the example that I like to use is intelligent and attractive. And this is what we use when we come to truth tables. We're going to introduce these later. But everybody in here is intelligent and attractive. That's the best thing. You all got it going for you. See how that's cool? We're all intelligent. We're all attractive. Okay? But there are people out there that are missing one of these two qualities. Sucks for them. Right? You might be intelligent, but not attractive. You might be not intelligent, but attractive. Following so far? You might be intelligent and attractive like all of us, or you might be not. You might be not intelligent and not attractive, which is different than not intelligent or not attractive. Do you understand that? Not in the English language, it doesn't really make sense. When you throw a not and you use an or, what does it mean? But it's different. So if I say, hey, you know what? It'd be a dog on somebody. If I'm like, hey, you're not attractive and you're not intelligent. The and means what? Both of those are true. So the and means both statements are true. So that person has nothing going for, right? Well, they could have other things, but you know, they're not attractive and they're not intelligent. Everybody got that? What does it mean if I say to some random person, and I wouldn't want to because that's not nice, you're not intelligent or you're not attractive? What did I just do? What does the or statement mean, and how is it different? Only one has to be true. And I'm going to stress has to be true. If that's the case, only one has to be true. And I just said to this person, you are not intelligent or you're not attractive. What am I saying to that person? This is where it's tricky. I just threw an or in there and changed everything. It doesn't mean they're both. It means I'm actually telling them they're what? Yeah, one or the other. So the way to think of it is it's the same way to say you're either attractive or intelligent in a positive way. I could have just said you're attractive or intelligent, but you're not both. You see what I'm saying? I could turn that into an either or and say you're either positively attractive or you're positively intelligent, but you're not both because you're negative for one of them because I just said that or in the middle of it. Does that make sense to you guys? I'm leaving it open. So if you said that statement, you are not intelligent or not attractive, you're actually telling them they are one of them. You're leaving it open for them to be one of them. And so now the human language versus actually logic is a little different. That statement sounds like they're not both. Okay? So only one has to be true. And then if you start throwing nots in there, it takes the opposite. Nots just negate something. Or takes the opposite. So if you throw a not with an and or an or, you got to know how it works. All right? Now, what if I said something like, you are not attractive and intelligent? If I say you are not attractive and intelligent, does that mean you're not attractive and you are intelligent? Or does that mean you are not attractive and you're not intelligent? Because I didn't put another not in there. Do you see how the importance of not needs to be everywhere? If I say you're not attractive and not intelligent, you're neither. But if I say you're not attractive and intelligent, I just said you're intelligent. That's logic. Are you able to read that? Does that make sense to you guys? If I say you're attractive and not intelligent, well, that's a little different. I mean, that's easier to read because I now said you're attractive to start with, but you're not intelligent. Maybe put the not towards the second half if you want it to reign true. In any case, when you start throwing these ands and ors together, this is what logic is, and this is how you can build up bigger if statements in your program. But if you don't fully understand these keywords, and you don't fully understand the logic that's behind the ands, the ors, the nots, and the neither nors, either ors, and what they truly mean, when you start stringing a lot of things together, if statements become a little tough. Okay? And you got to make sure your programs work. We're going to try to control your statements and make them easier to understand and make less of them. And like say, well, I'm going to make a small one here, and then I'll branch off and make a small one there. Because you can do what's called use braces and make nested if statements. But we'll get to it later. But ultimately, a nested if statement is saying you can take an if and put it within an if to make that first if statement a little easier to read. So you're breaking down the ifs and saying, well, if this is true, then you move forward. And if this is true, then you move forward. Okay? Otherwise, either are false or just kick the whole thing and move on with the program. This will all be taught. But I'm trying to get back to these three keywords today and stress the importance of them. How are we doing?